Hey guys, so the first thing we're going to do is finish up for fourth period and sixth period. Second period, you guys had enough time to get through this. We shaved some time off somewhere, so we got a little bit farther. So fourth and sixth period, you need to find this spot where we were finishing using the quotient rule for this mess of a position function right here. So let's get to that quickly. I'm going to go ahead and get started. I'd like to go ahead and lightly box this one up because technically on the AP exam that would be an okay final answer. That's been kind of a common theme. We'll talk about boxing up kind of early, but we're going to keep practicing the review process and simplifying. So next up, I just rewrote these without the fractional powers on the top. Also, I had the square root that's being squared. That turns into a nice little t over there. That also is a great final answer. Let me move that over so you can see it. There we go. All right, so let's keep going. We've got some other ways we can write this. Let's start with, I could distribute this 1 over 2 root t. That would be good. It doesn't distribute all the way to the rad t, so we'll have a rad t to start. Then we'll have a minus 1 times the 2 over root t, so that'll be 1 over 2 root t. Don't forget it's a minus. Next we have a t with the 1 over 2 root t, but it's also a minus because we had the minus out front. So that'll be a minus t over 2 root t. All right, and then the bottom doesn't change. That's just a t. Then somebody comes along and says, hey, wait a minute. You can't leave a radical on the bottom of that fraction. Or maybe better yet, they say don't leave a fraction within a fraction. So what I'd like to do, grab a different colored pen so we can show what's happening here, and it'll be obvious later what we did. We're going to multiply the top and bottom of the big fraction by the rad t. That'll get rid of the rad t on the bottom. It'll leave some fractions up here, but that's okay. Let's see how that changes what we've got here. Now rad t times rad t is simply t. Then we got rad t times 1 over 2 rad t. The rad t's will cancel. You'll leave a 1/2 and it's negative. And then the last term on the top, the rad t's cancel on top and bottom. You have a minus t over 2. So that is the same as like a 1/2 t. You can think of it that way as well. So then on the bottom, I just put a new rad t on the bottom, so that would be t rad t. All right, so that's a pretty decent looking answer. Okay, fine. Then somebody says, wait, on the top, can't you put those together? Of course we can. This is 2 over 2 rad with a t on it, 2 over 2t, and this is 1 over 2t. So that turns into 1 over 2t. In other words, a whole t minus a half a t, that would be a half of t. And then we got a minus 1/2. And we still have a t rad t on the bottom. Another okay answer, right? I kind of dig that one as well. So that's cool. Let's see. What else? We could maybe multiply the top and bottom by 2. Do you see why we would do that? Maybe get rid of that 2 and that 2. So that would get us doubling a half t, that would be a 1t. Doubling a half, that would be a 1. On the bottom, we got a 2t rad t. Again, another fine answer. I like it. What I like about this is you've got a t minus 1 on the top. That's easy to figure out when that's 0. That's going to be important to us. Because remember, we just found a derivative, also known as the slope of the tangent line. And if you want that slope of the tangent line to be 0, just make the top 0. That happens when t equals 1. Okay, let's go a step further. Maybe somebody comes along and says, yeah, that's a beautiful answer. I know you're in calculus and you think you're cool and all, but we're not allowed to have radicals on the bottom. That's just, it's an old school rule. We don't want to have that. So then you could go multiply by rad t on top and bottom again. And let's see what that does. So let's see, that gets us a, let's leave the rad t outside this time, and we'll leave a t minus 1. And second period, if you're watching this, you're probably thinking, that doesn't look like ours. I might have done things a little bit different order this time, and that's okay. Next up, on the bottom here, we have a 2 times t, but there's also a rad t times rad t, and we know rad t times itself is t, times another t is t squared times a 2. So we've got a 2t squared on the bottom. So that's a pretty good looking answer. We could keep going and going and going, but I'd rather not, and I'm guessing you probably agree we should stop at that point. Okay, so there you go. Lots of different ways to say the same exact thing. In the end, we're going to try to take this derivative and find out when it's 0 and when it's undefined. That's coming soon. But for now, just rest assured, you need to be able to do all these different notations, okay, with whether it's fractional powers, negative powers, you name it. Okay, at this point, I'm going to flip it over, and I've already kind of started just by putting a title up there, Trig derivatives. Trig derivatives. I mean, take your two favorite things about math, right? Trigonometry and now derivatives, put them together. It's going to be the best day ever, I promise. Just kidding. It's not going to be the best day ever. Well, it might be the best day ever. Who knows? All right, first thing I'd like to do is a little bit of review. Some old stuff. So we're going to start with just that. We're going to say old relationships. I'm going to move quickly through these, so hopefully you can keep up. Tangent is equal to something over something. If you know what it is, say it right now. Okay, good. I think some of you said y over x. Some of you said TOA, O over A. That's true too. But how about trig functions? Sine of x over cosine of x. Then we could flip that over, and then we got the cotangent. Cotangent of x is cosine of x over sine of x. Let's not get lazy. Don't put tan equals sine over cosine. We need tan of x equals sine of x over cosine of x. Next, let's go secant of x. That would be 1 over, if you know it, go ahead and write it. And then we'll have a cosecant x over here. It's 1 over, and again, if you know it, just write it. Okay, for the secant, it's 1 over what now? Yes, I hope you said this. And then the other one, of course, would be 1 over sine x. All right, so that's nice. Next, we've got some specific Pythagorean identities. They came from Pythagorean theorem. Maybe you'll recognize it. I think you know what this is equal to. That would be 1. Now we could go through a long involved process like divide this by cosine squared, you'll get a tangent squared. Divide this by by cosine squared, you get a 1. Divide this by cosine squared, you get a secant squared. So now we have a new formula involving tangent squared and secant squared. And then of course you could take this and put it over here and then make it a cotangent squared instead. And that would make it a cosecant squared instead over here. In other words, divide everything by sine squared. Take this, divide by sine squared. In fact, let me cover this up for a moment. Oops, I dropped it. Can I get in? It's cool. Thank you. Divide this by sine squared, you get a 1. Divide this by sine squared, you get a that. Cotangent squared. Divide this by sine squared, you get a cosecant squared theta. All right, so those are your Pythagorean identities. Looks good. With that little bit of review, let's take a break from the notes, and I want to show you something in the calculator. I'm going to graph something here, and I want you to just think. You don't need to get your calculator out. Don't worry about that. Let's just have you watch. So check this out. I'm going to hit graph. Let me pause it right there. Okay, that's pretty good. Let me zoom in a little bit more so you can see what's going on. So what I have here, let me slide this up a little bit. There we go. So what I have here is a trig function. You maybe saw it on that previous screen. I was trying to be sneaky, but I think maybe you saw it. So what is this trig function right here? It is starting at 0, ends up at 0, it maxes out at 1, bottoms out at -1. That would be sine of x. If I hit enter, you're going to see the derivative of sine of x be graphed. Here it comes. And it's nice and bold, so you can see the difference. Now, hopefully you recognize that bold graph. Again, this is 0 and 2 pi, maxing out at 1, bottoming out at -1. And what would that function be, the new one? That would be the cosine of x. Let me show you what it is I put into the calculator. I put sine of x, and then I gave a couple of horizontal lines so we could see where it maxes out and bottoms out, right? Just to give you a little frame of reference. And then we've got the derivative of that first function. So this right here, turns out it happens to be the cosine function. Okay, so that being said, we're going to go ahead and give you some of the derivatives right now. And now, the derivatives. First up, sine of x, the one we just talked about. And you know this one now because you saw it. Here we go. So go ahead and write over here. You can write, and now the derivatives. d dx of sine of x, you just saw it, it's cosine of x. Off to the right of that, let's do d dx of cosine of x. Now you might think you know what that one is. If you think you do, go ahead and put it over there. I'm reading your mind, and I kind of agree. Not completely. Not completely. Let's see if we can figure out what's up by using the calculator to investigate. So I've got cosine of x, max out at 1, bottom out at -1, so that'll just give me some nice little guidelines. And then the derivative. Here it comes. Okay, there it is. There's the cosine, and here comes the derivative of cosine. Does that look like a sine curve? The answer is yes. It looks like a sine curve, but not the original, not the mother function of all sine curves. It turns out it's upside down. So sneak a negative sign on it, and there you have it. Now you know the derivative of cosine is negative sine of x. Okay, next, we're going to come down here underneath sine of x. We'll do its reciprocal function. That'll be cosecant of x. And this one, I'm just going to give it to you. There's a way to derive it, but we're not going to do that for every single one of these. We're just going to memorize some of them. And then to the right of that, we'll go the derivative of secant of x, which you might guess looks kind of like that. This one has a cosecant, cosecant, cotangent. Drop the cos. And there's no negative sign either. And it's secant x tangent x. Again, I don't expect you to know that or to have a reason why it's that. Right now, you're just going to trust it and trust me and write it down and memorize it. And then we'll give you some ways to remember it. We'll also give you some ways to build it, but maybe not all today. The next one, we've got two more, tangent and cotangent. The derivative of tangent, it turns out it is secant squared x. And then the derivative of cotangent of x would be similar to that, but put a co on it and put a negative sign on it as well. Negative cosecant squared x. Now, there's something special going on, a nice little way to remember some of these. You'll notice some of them were negative. In fact, let's box up any one that was negative. Box up that one, turns out to be negative. Box up this one, turned out to be negative. And box up this one, it also turned out to be negative. Now study those for just a moment. Do you see something that would be a nice way to remember that those will end up with a negative? Cosecant, cosine, cotangent. They all start with a C, and you end up with a negative sign on the right side. So awesome if you caught that. If not, it's a great way to remember it. Then we've got the other ones, like these two guys right here in the middle. I call these the repeaters. That's just my name for them. I call them the repeaters because when you take the derivative of cosecant, you end up repeating back to me the cosecant, and then you put some more stuff on it. The derivative of secant, you repeat it, and then you put a little bit more onto it. All right? And of course, this is the negative repeater. This is the regular repeater. A negative repeater because it's got a C that starts it off, so you're going to have a negative. All right? Let's go ahead and draw a line there. So you have your 6 main derivatives. You're just going to have to memorize those. We do have a way to find them, so I'm going to show you with one quick little example how to do that with one of these. So let's go talk about how to find d dx of cotangent of x. That looks like a G. Got x? No, cotangent of x. Find the derivative of cotangent of x knowing only the derivatives of sine of x and cosine of x. So we're making the assumption that you know a little bit about derivatives of trig functions. We're saying you know just those two guys up here. You don't know these other 4 down here. You know the 2 basic ones, sine and cosine, and we're going to use that information to get us through this. Well, let's first do a rewrite, which has kind of been a common theme these last couple of days. You see some crazy algebra with weird negative powers, fractional powers. We do a rewrite usually. Well, let's do that here. Cotangent is also known as what over what. And you could say 1 over tangent, but I don't want that. I want sines and cosines, and it would be cosine over sine. So I don't know if you can see where we're headed with this, but I now have a quotient. That's a big clue right there. Yes, we are about to do the quotient rule. All right, the bottom is just going to be sine of x quantity squared. The top is going to have something times something minus something times something. That's your template. That's your usual. And does it go fg prime or gf prime first? Hopefully you said gf prime. Now remember, gf prime minus fg prime. Remember, that means this was f and this was g. So let's go ahead and plug everything in. In fact, why don't you go ahead and do that? I'll give you a few seconds, and then I will fill mine in as well. All right, so g should have been sine of x. F prime is the derivative of cosine. So we have to go back to our little list over here. That would be a negative sine of x. Next, we have f, which is cosine of x, and then g prime, which is the derivative of sine. So derivative of sine, back to our list over here that we just learned about. That would be a cosine of x. And there we have it. Okay, so let's clean this up a little bit. We get to multiply these two together. So that will get us, let's see, negative sine squared of x minus cosine squared of x. And the bottom, we don't need the squared on the outside. We can just go sine squared. That's kind of the typical way to write those. And then, I don't know if you noticed the top, but the top looks a lot like our first Pythagorean identity, except we have a negative sign to worry about. So if we were to factor out a negative 1, that'll leave us with sine squared x plus cosine squared x. And then we got a sine squared x on the bottom. And we are almost there. Maybe you can see it at this point. Let's go ahead and wrap that up. So that turns into negative 1 times, what's this mess? 1. And you still have a sine squared on the bottom. So we have negative 1 over sine squared, which we know is the same as negative cosecant squared. There it is. And of course, we knew this because I gave you the formulas about 5 minutes ago. But now you have a technique. You have a way to get to it, which is kind of cool. All right. At this point, I'm going to stop the video for now. Let's make sure you get caught up. Make sure you've got everything you need from this page. We're about to do a bunch of examples, but they're just going to be by the way of doing a bunch of even problems from the book. So I'll put them up on the next video, starting in just a moment.